Okay, good morning, guys. I wanted to do a bit of a review video to go over everything that we've done in this factoring stuff. Believe it or not, I don't even want to know how long ago we started this giant yellow booklet, but it's been a really long time. So it's time to get it done with and move on with our quarantined math lives. Okay, so a quick review of factoring. You're going to be given different situations, and at the end of this week or early next week, you're going to have an assessment, like a test of some sort, that you're going to need to be able to differentiate between these different things and when to use sort of which technique. So I wanted to make sure that was super clear. So we started off, I think it was topic number 4, with just polynomials in general. So the first thing you're always looking for is to find a GCF, greatest common factor, for the coefficient and constant and the variables in the polynomial. So you're looking for what's common for both. So our very first exit slip, since we've been online, had to deal with these. So an example would be 6c plus 4c squared. Well, and let's add on 2, plus 2. If I look, I could take 2, no, just joking, I don't want it to add 2. I could take 2 out of, or divide out 2 from the 6 and the 4, but you don't want to forget about the variables. So I can also take c out here. So that leaves me with 3, because remember, what's inside the brackets is what you would multiply this greatest common factor by to get back to the original. So 2c times 3 would give me 6c. Then 2c times 2c again, right? 2 times 2 is 4. C times c is c squared, is what would get me back to that c squared. So my greatest common factor is the 2c. And then I divide that out of each term to find what's inside the brackets for that polynomial. So look for a greatest common factor right away. Pretty much no matter what, you're looking for a common factor, except for this one, but we'll talk about that. Sometimes you might have to combine like terms and then do that, finding the greatest common factor. Most people did fairly well with this, but there's always integer issues. So let's say we have 2x squared plus 3x minus 2 plus 4x squared minus 5x. Okay. So if we combine our like terms, meaning same variable, same exponent. Same variable with the same exponent. And I'll send a copy, or I'll post a copy of this paper on our classroom so you can read through it afterwards. But let's look at this. So we have 2x squared and 4x squared. So that makes 6x squared, okay? Variable exponent, x squared. For our x's that are just by itself, 3x and negative 5x, brings us to negative 2x. Careful. That's negative 2. 3 plus negative 5 brings us down to negative 2. And then our constant is all by itself. It's just negative 2. So if we look at this, we can factor out a 2. And that leaves us with 3x squared minus x minus 1. Okay? Again, we can check this. Did we do it right? 2 times 3x squared, that's 6x squared. 2 times negative x is negative 2x. 2 times negative 1 negative 2. Since we get back to our original, we're correct. And generally when I've taught this unit, I've marked this unit harder because I'm expecting you to be able to double check your answer when you're factoring. You can always double check, multiply it out, and make sure that you getting back to your original, sorry, that's not quite in view, polynomial. So I've seen a few people on the exit slips double checking their work. That's awesome. The textbook often says check by expanding. That's what that means. Multiply out your answer to make sure that you have it correct. Okay, so when there is no coefficient on x squared, so we look at that like this. We have x plus x squared plus bx plus c. So we label these b and c and a when we get into here with the coefficient on x. Then we say ax squared plus bx plus c. And that's just labeling the coefficients and the constants just to keep them kind of straight. So let's do an example here where we have no coefficient on here. So that's a 1, we could think of it. So we have x squared minus 2x minus 8. So we use an x in this one and we use an x in this one, and they're used a little bit differently for each, so be careful. Up here, we're still multiplying these. We have negative 8 up here, and down here we have negative 2. We're still looking for factors that multiply to get that negative 8 and add to get the negative 2 at the bottom. And so we go 1, negative 8. Nope, that doesn't add up to negative 2. 2, negative 4, or negative 2, positive 4. One of them has to be negative, so we multiply to get the negative. And I can see that will work. Negative 4 plus positive 2 gets me that negative 2, and when I multiply negative 4 times 2, that gets me to negative 8. So those are going to be my factors that I need. It's a really simple step from here, and people that did these, this was topic 5 on the exit slip, did super well. So that just looks like this: x minus 4, x plus 2. And yes, you are done. But you can check to double make sure. So let's see, does this bring us back to here? Well, x times x is x squared. X times 2 is 2x. Negative 4 times x is negative 4x. And negative 4 times 2 is negative 8. When I combine these two, because they're like terms, same exponent on the same variable, I get my original polynomial. Hurrah! There we go. So it's correct. I've checked it. I know I'm good to go. I have the right factors. So those are fairly simple ones. Our next one gets a little more complicated. So ax squared plus bx plus c. So the first thing you're going to do here is check for any common factors. Okay, so here's my question. 24h squared minus 20h minus 24. So check for common factors. And in class right now, I'd ask you if you could find some, but since I'm not with you, I'll have to do it for you. You're welcome. So the common factor for 24, 20 and 24 again, is 4. So I'm going to divide that out. And what I have left inside is 6h squared minus 5h minus 6. I'm going to forget about the 4 for a little while. I'm going to find the factors next. So I'm going to use my x once again. Sorry, my tripod gets in the way here sometimes. I'm going to use my x once again. Here I'm using a times c and again b at the bottom. So a times c. Forget about the 4 for right now. I saw a lot of people trying to use the 4. And seriously, don't worry about it until the end. So we have 6 times negative 6. That's negative 36 and negative 5. I'm going to list my factors to find them. 1 times 6. Sorry, not 1 times 6. 1 times 36. 2 times 18. 3 times 12, I can't see something that goes to negative 5 yet. Here, let's do the next one, 4 and 9. Aha, if I have negative 9 plus 4, I will add to get negative 5, and I will multiply to get negative 36. So, again, forget about the 4. Take that trinomial that's left, 6h squared minus 5h minus 6. Decompose b, and that's step 3, and we're going to do it above here. Decompose b, meaning the middle term. So I'm going to pull my 6h squared over here. My negative 5h, I have negative 9 and 4. I'm splitting negative 5h into negative 9h and 4h. Which one is going to go with the 6h squared? In this case, it probably doesn't matter because we have 6 on both sides. I'm going to pull negative 9h. Okay, this is negative 5h is being split into these two factors. You're not done like you are over there. 4h minus 6. Now, step 4 is to find the GCF in each binomial. So we have 6h squared minus 9h and 4h minus 6. So the greatest common factor here is 3 and h. They're both divisible by 3. I'm going to rewrite it here. 3h. What would be left inside would be 2h minus 3. These are both divisible by 2. Can't take out an h because there's no variable on the 6. So then we'd be left with 2h minus 3. We want these. Can you see this? There we go. We want these two to be exactly the same, which they are. So finally, write both binomials. You're not done quite here. You're going to take these two, put them together, 3h plus 2, and this you're going to write once. And if we think about this, that's what's happening. 3h times 2h minus 3. That's what we're doing. 3h times 2h minus 3 when we multiply this out. And then 2 times 2h minus 3. So we're just simplifying the way we're writing this. We could check this. You should check this. But I've run out of space and we're running out of time on this video. So we're going to keep going. Actually, I'm going to split this video into one more. So I'll end it there and I'll start again.